So last week we actually tried to, by way of reminding ourselves or recapping some of that coverage, coming from several weeks of a break, weekly meeting. So we started the topic, taking benefits of machine learning modeling, irrespective of your background. So under our important clarification series, with the logo, always let the data speak. So we started by way of letting us remind ourselves about what it takes to learn machine learning and to practice what we have learned. That is very, very important. So the more practice you have, then the more comfortable and competent you also become. So we strongly also encourage us to participate in teams. That is some of the research group that have been created in a WhatsApp group and Telegram group, so that you can be able to have a kind of collaborative settings where ideas could be raised and then can look at it together in your group. And also, we did mention some of the good news of our members who are totally new to machine learning and how over time they have been able to implement successful application of machine learning in their various backgrounds. So, and some of them already got their work published in the top journals in their area of specialization, while some also are presently having their work at various stages, ranging from under review to even draft preparation and experimental preparation or ongoing experiment. So the idea is that irrespective of your background, you can actually make use of machine learning. So we did explain last week a couple of points. And I remember we stopped at, after describing the 6-point base, machine learning model building steps, the 6 steps opinion. We discussed this, and that was where we stopped last week. So for the case of those who might have missed that, so we can actually check our video out in the provided link. So today we are moving on to look at the remaining other opinion or other steps, and other few clarifications we want to provide for us. So again, on machine learning models building step, there's some steps. Sometimes it becomes even more elaborate. So like defining the objectives, data gathering, data cleaning, doing some exploratory data analysis, little. So feature engineering, to carry out feature engineering. So feature selection, model building, the model evaluation, and then optimization of the model also is very important. And finally, you have conclusion of what you have done. So sometimes, as we have here, we can actually sometimes look at it from data science point of view, the data science point of view, which is more detailed, because machine learning is one of the tools that are often used for data science. So what is the difference between data science and machine learning? I hope in the future we're going to have the opportunity to discuss more on data science specifically, and what differentiates data science from machine learning. Is data science machine learning? So is data science statistic? What are the differences? How can we differentiate between the two of them? In future, we should look out for an opportunity to where we're going to be treating data science more. So we're able to know the difference between data science, machine learning, statistic, and also for others. Because presently, you see people using them interchangeably, but in reality, they are different concepts. Of course, you have a lot of things common. Data science, the big umbrella, so where machine learning is one of the tools of data science. So we look into this one, like I said, later engagement, inshallah. So this is generally supervised machine learning framework. So it's generally accepted that you have, of course, you have your data gathering mode, you have the data pre-processing, So we have the data preprocessing. These are, it can be as much as possible, but then some of them could also be optional. So we have the model building, model checking your model or validating the model. Here you try to optimize the parameter. If the parameter okay, if not okay, then you go back. Or do you need to refine your model parameter? You have to go back. It means there's a loop here. You keep looping around until you are able to achieve. There's no need for more optimization. So everything looks good. And then you have the model validation. Finally, double check what you have done to make sure that it's working fine. So, and then prediction using the model, and then result analysis and identification of hotspot. So by this can be used for any basic machine learning modeling task, and it's a little bit more detail, and also it involves the idea of the fact that machine learning procedures, they are not just one at a go, but rather it's iterative. You always have to come back. See, you might not be able to get what you want at a point, but you might need to go back to previous steps, make it better, especially when you want to use the principle of let the data speak. Let data speak. This is very, very important to pay attention to. So at the beginning, after once you gather your data, prepare your data ready, data preprocessing is a long process, could be as many as possible. However, we've discussed it in our previous videos. We can check it out, some of the data processing. How much time are we supposed to spend doing data preprocessing? Because sometimes it's also good for you to let the raw data speak. Let us see how your data is performing ordinarily before you start mutilating the data. Because sometimes data preprocessing involves mutilating the data. You have to remove some. You might need to add some data, some abstract data or arbitrary data or fake data, as we call it. So first of all, run the experiment using the original data you have, record what you have, because what you are getting will be one of the strong bases to actually justify the need for you to carry out further data preprocessing. So this is my own perspective on this, in line with the principle of letting the data speak. So if you start from the beginning and you do a lot of too much preprocessing on your data, you might end up just doing modeling with not the original data, fake data, or as the case may be. So first of all, work on the original data. Even if it's not giving you the best result you expect, it's good. At least let us see how the data itself has been maybe it's originally distributed, and the nature of the data set, and what information can we bring out using our machine learning algorithms. So once we are done with that, so all the steps are well taken care of. So we can also look at it at another perspective. So where we are here, the data source. So either you have two data sets being merged together, you have the combined data set, you have different preprocessing methods, the percentage splits. So and other stuff we will actually come up with. Make your experiment very clear. In any experiment you are carrying on in machine learning, it's very good for you to bring the framework. Make your framework very clear, very clear. It's very, very important. So that one of the conditions of machine learning experiment is that your experiment must be repeatable by someone else. Someone should be able to repeat your experiment. So this is one of the conditions for reviewers to actually have put a null to toward the acceptance of your paper. Of course, that is in very reputable journals. So which is what I also always recommend to people. So whatever is what they not told is what doing well. I don't recommend spending a lot of time and then only to throw it in a very junk journal where they are not even going to review it, just only interested in the money. So it's not academics. That's not what we promote. So once you carry out this particular procedure, it's very, very important that whatever you have done must be made very clear in your report. We also discussed this before on that. You can check out our videos on how to use machine learning for research. Now, Furthermore, we said always let the data speak. This is very, very important. That is, the idea is that you start with the raw data set before applying too much preprocessing. Of course, there's some preprocessing that you just need to do that even the algorithm might not work. For example, some algorithm, if there is missing value, you cannot use them. So it means you need to fix the missing value. We've described extensively in our previous videos what are the preprocessing methods you can use, how can we treat missing value, replacement, finding the mean, and also for that. However, in some other environments, like most of the weaker environments, you might be able to run your data set even with the presence of missing data, depending on the algorithm we are selecting. So always start the raw data, except if it is impossible for you. Don't go too much. Like for example, normalization. Some people will start right away, they want to normalize their data set. It's not necessary. Run the original data set already. Run the experiment using the original data set. Sometimes you get better results without normalization, because normalization works when you have a situation that the variables or the features, they're having huge differences in the values that are actually within them. You have a particular, maybe you have a feature 1, x1, and the range of value is like maybe between 0 and 10. You have another feature 2, the range that ranges from maybe 1,000 to like the billions of numbers. So when you have this kind of variable and then variable competing in the same modeling, they might likely affect the outcome of your modeling. So what is recommended is you try to normalize the data. Instead of having one to be 1 billion, another one is just 0 to 1. Sometimes other could even be 0 to 1.5. Very small numbers. When you have them, it could actually confuse your modeling. It could. You see, mark my word. It depends on the nature of the data itself also. In this kind of, where you have huge discrepancies in the range of each variable, then it is recommended to have normalization. Even at that, you need to run the data set as it is. Don't do any normalization. Go ahead and run the experiment. Note it down. Do your feature selection, note it down, and then you might need to run another experiment where you carry out normalization. Because the normalization itself, there are several methods of carrying out normalization. So you can even compare it, actually. It's going to be the basis of comparison. Okay, result before normalization, result after normalization. So that is why it's always better to start with the raw data set, the original data set given to you, before you start implementing different ideas of preprocessing. Now, so then always use the iterative process idea. Very, very important also. Always use iterative process. That is, you put in your mind that you might need to go back. You might need to go back. So in that case, you don't need to finalize everything at a go. Give room for it. Relax. Start with simple. So remember that machine learning is not a dogma. That is, try different algorithms and options. We had the lecture also in the past where we discussed this concept that machine learning is not a dogma. That is, there's no machine learning algorithm that can guarantee that it's going to give you the best result always. In fact, if you see someone saying the best machine learning algorithm is this, they say that no, such person doesn't seem to really understand the intricacies behind the principle of machine learning. There's no algorithm that can guarantee you good result in all situations. So that is why we always recommend try different algorithm and start from the simplest. See, try simple algorithm first. Things like k-nearest neighbor, naive Bayes, naive Bayes, decision tree, before you start going to more mathematically based complicated algorithm like support vector machine and also for that. So following the principle of always let the data speak. So once you carry out an experiment, analyze it, you say, okay, it's not yet okay, then let me try to normalize my data. Maybe my data is not good. Let me try to do further pre-processing on my data. Maybe I may actually to change the pattern, the type of data. Maybe you had missing data. How did you treat the missing data? Using mean, that is the average, or replacing with mode, the most common value in the feature, or there are so many other methods of missing data. Maybe that is where your work is actually having issue. You might need to revisit them. And then try a couple of other types of missing data treatment. So always remember the data plays a vital role in whatever outcome you're going to get. So, and take the next step based on what you can deduce from the data modeling outcome so far. This is where experience matters. You see, sometimes you may need the support of your supervisor or somebody who can provide guide for you, because sometimes you think you have exhausted all the options you think, but yet your result is not improving. You might need to consult an expert who from his own experience might be able to guide you that, oh, have you tried this? Have you tried this? Have you tried this? Because at a point in time, experience really comes in that, oh, okay, try this idea. No, you don't use this normalization type, because there are several normalization types. Based on experience, can you check out this normalization type? Perhaps that could be what you actually need to achieve your intended goal. So don't let us underrate the idea, this kind of procedure, especially. Always use the iterative process. Remember, machine learning is not a dogma. Try different algorithms and options, and then always let the data speak. And your next step to be taken should be guided by experience. Based on experience, talking to your supervisor or senior collaborator who actually might possibly have more experience to guide you. So this is the iterative machine learning model building framework. So where you have your data, you start with your data set. See, either you do feature engineering and so forth others. Then you have the algorithm where you have modeling, select appropriate algorithm, starting from the simple one. Then move ahead to check the performance measure. To check the performance measure. If the performance measure is okay, if not, you are not yet satisfied, then go back. You might need to go back to the modeling by doing hyperparameter optimization, or by even changing the algorithm. KNN, decision tree, keep changing them, use as many as you can. Sometimes you might need to go back to feature engineering, or totally go back to your data preparation. That is the iterative process of machine learning. So you don't expect that you're going to get it at once. No. Sometimes you go as many times as possible before you finally get it right. Of course, don't forget taking appropriate guide from, if you have the opportunity, from experienced people who might actually guide you in case things don't go the way you are actually expecting. Now we give a couple of advice, different angles to solving problems using AI-based solution, depending on your background. Like I said, machine learning is for all. So that's why these days you have even top universities promoting codeless AI. You can deploy AI without writing a single code. Everybody should be able to use it. Everybody should be able to benefit from it. However, to the people from diverse backgrounds, so if you are not computer science people, so this is not an exhaustive list, this is just advice and suggestion. So to those people from different backgrounds, aside from computer science, then we can clearly think and brainstorm about your area of specialization or interests, and see how you could actually possibly use machine learning model towards improved outcomes. Consider your own area. What is your own area of specialization? Name it. Machine learning will possibly work for you. So then further think of how you can improve upon your earlier achievement through coming up with more advanced machine learning algorithms. Sometime after maybe successfully deploying your first machine learning models, and you successfully presented it maybe in a conference or journals, don't stop there. Look for that. How can I even make it better? by coming up with more advanced machine learning algorithm or techniques like hybrid or ensemble modeling, as the case may be. These are some suggestions of what you can actually look for if you are not having a huge background in computer science. To the people from computer science related background, of course, you also clearly think and brainstorm about areas that may be in dire need of improved outcome if provided with machine learning model capability and step in. You see, you may also have to go in the application area, look at your area and see where you think people can benefit. Then use your knowledge of machine learning or AI and come up with a problem definition that you can actually solve for, that will possibly improve the life of people around you. 2, further think of how you can improve upon your earlier achievement through producing more advanced machine learning algorithms, based solutions, or techniques like hybrid or ensemble modeling. So try to also say, okay, the initial one you have done, can I make it even better to increase the accuracy or to reduce the number of features that we use? Imagine you build a machine learning model for medical prediction with 25 features. So if you ask people to come and get 25 features before they can actually use your machine learning model, that's going to be a burden on them. Can you try to see how you can bring down this number to maybe manageable number of medical lab works, like 5? From 25, can we bring it down to 5 tests? Think of how you can improve what you have done. And of course, being computer science related background, think also of how to develop new machine learning algorithms. How can you develop totally new algorithm by studying the one that is available and offer a totally new idea that you can use to address, hopefully, a new system, or even new hybrid, or a totally new ensemble framework that are previously unknown, benefiting from the existing stacking, boosting, and bagging principle of ensemble. Can you come up with new ones? Consider your background. So this is how I kind of dichotomize based on our background into some of the stuff we can look for. But that doesn't mean, even if you are not computer science, if you don't have computer science background, you don't need to have also a limit to your imagination and idea that we can actually try out towards improving your previous experience at modeling using machine learning. So it means wherever your background, no matter wherever your background is, you have the full potential to take huge advantage of machine learning modeling. Now, these are some of the where you might think of focusing attention on, or what we call successful machine learning applications. For example, like in bankruptcy prediction. Prediction. So in bankruptcy prediction, imagine these days, enlightenment matters and education matters. So the governments, federal governments of the world are now encouraging youths to think of how they can have startup. And that's supposed to be the real thing. So no government can provide job for all the citizens. It's not possible. It means people can actually make it in life more by trying to see how can they set up their own, what can they give back to the community. Look at services that needed to be provided. How can you provide in an easier way? These are some of the education and enlightenment we need to give to our youths. People need to think out of the box. The whole system whereby, hey, you just go to school, you're going to get a job, and then who is going to give job? This is the reality. So, and reality has actually shown that thinking of how you are going to have your own job is the best way you can actually live a life, rather than depending on salary that might sometimes not come, even if it comes, might not be enough for you. And also for other things attached to having a fixed salary. Of course, it looks secured, but at the long run, you find out very late as people are realizing that, no, it's not really the way to go. The way to go is to think of what you can do. Think of what you can do, what you can contribute, what services are missing, come up with a business idea, around that level, service provider, consultancy services, and also for that. However, as the government are encouraging people to have startups, a big problem awaits them. This is what we call bankruptcy. That is, you see a particular company starts getting people employed, doing well, suddenly something goes wrong. And then they follow up. Imagine what happens to those people who are already employed with them. Where do they need to go? So this is where this kind of application comes very handy. Can we have a bankruptcy prediction model that can envisage that something might go wrong with the company? Because company that got bankrupted before, there are some signs, some symptoms they were going to show before it actually happened, but we ignore them until it happened. So can we have a system that can kind of forecast such a thing so that the government can come to the aid of such company to prevent them from actually getting bankrupt? Because if you allow them to get to that level, a lot of people will be thrown off to the job market again, creating more imbalance in the system. So this was one of the social-based systems that we should be encouraged. So every system, every government should be able to monitor the startups. How are they doing? Are they likely going to have any problem? There's going to be anyone that's going to have any problem to prevent job loss. The government can come in tentatively, take over the company until things stabilize, then hand over it again to other intended maybe investors that will continue to make the company survive. So it's very, very big topic area that interested people, especially in the social and management sciences, can look into. Of course, the medical and biomedical related predictions, they are getting a lot of attention these days. So you cannot do it more because health affects everybody. Either you are a medical doctor, you are not a medical doctor, it doesn't matter. Everybody cares about health. And that's why in machine learning and data science, one of the areas of the use as case studies related to either business or medical. Because irrespective of your field, you have to think of buying and selling, if only you go to market to buy. And also another way is either you're a medical doctor or not, you have to think about your health or the health of your family or your friend and host of others. So it's another area that a lot of machine learning models can actually be built to facilitate, to prevent late detection of chronic diseases, and hopefully make health delivery even better. So, and also for other areas, think of it, computer vision, biosurveillance, this idea of trying to detect maybe there will be disease, outbreak, like flu before they actually happen. So, and also for the application, empirical sciences, irrespective of your field, you have your data from the lab. Can you build the model so that subsequently, instead of you spending so much time in the lab, you just use your model to predict the outcome. And then once it's tested, validated, you can rely on the data being generated without any issue. We have also social network debugging, predicting next incidents at home. Even at home, it's not left out what will happen to the kids. It could be some dramatic incidents. Based on historical data, these things can be done. And also for others, I said your favorite areas. You know your area. Anywhere you can think of machine learning is most likely going to work for you there. So check off it, data mining, playing game, fraud detection in industry, spam email detection, basket analysis in business, customer relationship. You want to know customer that might likely abandon your company before they do. So what can you do to them to prevent them from going? So now also further area we can take off. Finally, something unique to take note is that the applications are diverse, but methods are generic. That is the unique thing about machine learning for all. So the applications are so many areas you can think of. However, the same principle and generic approach can be used to solve any of the area that catches your interest, as the case may be. So it means irrespective of your background, then you can take huge benefit in modeling using machine learning, and a lot of our videos have been made in the past in our live session or recorded section, where we extensively describe how to go about developing machine learning and different concepts that are related to it, so that we can all benefit immensely in shaping the world we live using this kind of technology that is fast moving. Of course, we did mention last week that we asked us to pay attention more to the idea that we refer to as the ethical machine learning, if we remember. Yeah, ethical machine learning. This is very, very important. So ethical usage is highly emphasized because this day we started seeing people using AI for a lot of unnecessary, very bad things that can influence the society negatively. But rather, just like anything subjected to abuse, we stress it that we do promote ethical and responsible usage of machine learning modeling. Because there's a lot of areas we can benefit from. See, for example, in the surveillance, medical surveillance for people, we don't wait for people to complain of an ailment. We try to know earlier enough, because the human system is so strong that disease can be in people's body for years without them knowing. By the time they have a simple complaint, they say it's late stage. Then my question is, why do we need to wait for late stage? Why don't we do some machine learning based screening for people that can detect chronic diseases at a very, very early stage before the person even starts feeling any symptom? And medically proving that once you detect disease at those very stage, it's very easier to totally get cure for them. So these are responsible and ethical utilization of AI that personally and our team, we do promote, not the negative usage that some people are trying to promote these days, because we have to make it very clear. And finally, before we call it a day, we say, when a machine learning algorithm not needed? The machine learning algorithms are not needed when the relationship between all system variables, that is inputs, output, and needing, is completely understood. Then we say this is not the case for almost any real system. You hardly see any real life system that follows this principle, that you know the input, you know the output, and you know the hidden relationship between the input and the output. Is almost impossible. So most natural systems will have hidden relationship that we don't know, and that is what our machine learning algorithm want to determine for us. And once we know that, it automatically generates a program that we can use in future to do the estimation or the prediction or classification that we actually need. So this, to me and to us, hopefully, is a way that, irrespective of our background, we can all benefit from machine learning modeling. So thank you very much for listening. So this is what we are going to have for today, and we're going to give room for questions section if there is any. I wish you all the best. So for those people just joining us, we can check out our link, our YouTube channel, with several of our videos there. And also you can communicate with admin, Dr. Tijani, in the team, who chat with him, private chat him, to add you to our WhatsApp group, so that you can have also access to our list of the guidelines on how to watch our videos if you are just starting. So for better and well-guided participation, and also benefiting from some of the work we have done in the past. Thank you very much once again, and I wish you all the best. We can raise up our hand for recognition for questions if there is. Thank you.